Okay, so now we're going to loop through each character in a string. We have a string up here called n, and it's got 1, 2, 3, 4, 5, 6 characters in the word George. So I'd like to loop through that for int I equals 0, just like before, and we did a declaration, a condition, as long as I is less than 6, I plus plus. Now, you'll notice that I'm using the same variable over again, and that's because this is scoped to inside this for loop. So if you declare a variable, it only exists inside the parentheses here. That's called a key term called scope. Yep. And this is a little bit sloppy programming, because if I changed out the word George for Georgina or something, then I'd have to update this thing if I wanted to loop through all of it. So rather than going through a fixed value of the length, how else could I do that dynamically? Exactly. So n dot, and then you can just sort of see it suggests it right away, length. So as long as I is less than the length, keep on going. And again, the whole zero indexing thing, which is why we always just use less than. Okay, so now I can system.out.println, and I'll print out the n. And now you can print it a couple different ways. You can actually convert it to an array and just n at I. That's one way, but that's not best practice, and that doesn't always work. So what you really want to do is n.char@, and then the index of I. And so char@, is just a string method that we looked up before, and it just gives you the character at the given position. So when I is equal to 0, it will give you the 0 position. When I goes up 1, it'll go up as well. And so that's char@. Cool. Now, similar, if I have a literal string called word, if I only want to print the first 3 letters of that, let's system.out.println. If I only want to print the first 3 letters of that, I mean, if you're really cheeky, some people were just deleting that. That's not allowed. I meant I want you to call methods off of this. And so if I hit a dot after this, Java is really cool. It'll give me, I can call methods off of a literal string. And so I can give a substring, and then it'll just beginning and end index. I want to start and include the first one, and the second one, and the third one. So, but I know the address is 0, 1, 2, but the last index is non-inclusive. So what number do I use there if it's non-inclusive? Well, actually it's 0, 1, 2, and then non-including 3. So I want 3. So that means, and that'll give me the first 3 letters. So 0, 1, 2, and then up to but not including the address in line 3. And so now, if I ran this, I don't know if it would still work, I get were. And so, and that's the substring command. So take this guy and substring. And most students declared a new string called w and made that equal to word, and then just did w.substring. I'm just a little more efficient, so I just called the method right off of the literal string. So that's the difference between a variable and a literal string. All right, print all of the odd numbers from 1 to 100. So we'll start up a standard loop for int I equals 0, I is less than 100, I plus plus. Okay, now system.out.println, and I'll print just my counter or iterator, and that's why I is iterator. So I'll start my I, and I'll just print out of here. And now if I ran this, you'd see it goes up to but not including 100. So maybe I want to do including 100. Well, 100 is not odd, so I don't really care. But if I run this, this is evens and odds. So So how do I do that? So, and I don't want to start from 0. I want to start at 1 too. So one of the ways to check, there's a couple ways. You could do plus equals 2. That means every time instead of going up by 1, I go up by 2's. And so now these are all the odd numbers. So some students tried it out this way. The other way to do it is if you wanted to keep it plus plus, the other way to do it is to add a conditional. So we test if I were to divide that by 2, what do I get a remainder? So if I modulus 2 doesn't equal 0, then I print out. And what that means is if I divide by 2, I shouldn't have a 0 remainder. So if it doesn't equal 0, and remember, modulus is just the remainder operator, and so if this is it, then I would get all of the even numbers because it has a 0 remainder when divided by 2. But if you just want to switch that, you just say doesn't equal 0. It doesn't equal 0 when divided by 2. That means now all of the odd numbers. So that's the other trick. Okay, so this next one is create a scanner and take an input. This will be on your cheat sheet, so you don't need to ever really remember scanner. How to declare a scanner. Scanner is equal to a new scanner using system.in. And then it's going to yell at you saying you need to import scanner. So let's import scanner from Java util. And that imports it up here. So now it knows where to find the scanner. So that's creating a scanner and taking an input. So we'll just say, we'll make a new string called the username, and this is s.nextLine. So now it will create a string variable to hold the user's name and ask for an input. So if I ran this, it's sitting here waiting, and I could say George, and now it saved it. It doesn't do anything with it, but it's there. So, okay, so there's an input. Now, create a scanner. I don't need that because I've already created a scanner. Now, take a number and count down from that number to 0. So, instead of using next line, I'm going to use next int. It's just another method from scanner that you can see next byte, next int, and you can see its description. It just opens up a window and allows you to type into the console a number, and it will store that. So let's just create a standard loop for int x equals 50. If I wanted to count down to and including 0, what would I put as the condition? Mm-hmm. Right, greater than or equal to 0. So because I'm assuming that x will be greater at the start, and I want this to run right away. As long as x is greater than, and I'm counting down, so x what? X minus, right. And so that's easy peasy. And now I have this thing, and I'm not doing anything, so I'll just break right away. But here's the deal. Why is x being yelled at? Because I already made a variable called x. So that's why throwaway variables are dangerous. All right. Alright, so I'm just using k instead. Now I'm starting at a fixed number. And so one of the ways you can do this is I will start next in. So I'm actually calling the scanner right inside my loop. I'm doing this intentionally just to kind of blow your mind in that instead of creating another variable and then starting from that variable and counting down, I'm showing you that you can start right from here and do this. Why is this? Oh, dead code because it'll never run. Well, no, it doesn't know that it'll never run. Here, let me. Oh, it'll never run because it'll break right away, and it never gets to iterate down. So it's sad. System.out.println, and we'll print k. I'm just going to comment this out for a second so I can try this, and let's say 50. There you go. It counted down from 50. Right. And so that's what the scanner is doing. It starts at that point wherever I input this, and then and it'll count down by 1 until it hits 0 and include 0. I'll print that out. Cool. All right. That is that. That closes the loop. This closes main. This closes the class. So if I want to make another method, as our last step, create another method, then I need to create a method, and it's going to be public. It'll be static, and why I say that is the subject of this week's classes. And then it returns a true false, which is also known as a what? A true false boolean. Boolean, and it's called, I'll make anything up, is even. So I'll make a little function called is even, and it'll take an integer called num. And so now, here's the thing. Most students will write that if x divided by 2 is equal to 0, then return true. Else return false. Okay? That makes sense to most students. That, hey, if you divide by 2 cleanly, then hey, you're even. Return true. Kudos. Otherwise, return false. That's not returning the comparison. And you're going to hear me yell at you and other students about this, because this drives me crazy how inefficient this is. Because this is a Boolean value. This is resolving to true, and so you're returning another true. This is already a true or false. It's a comparison. So all you have to do is return the comparison. And so if that's true, then, oh, I'm sorry, I'm using x. I meant num. Sorry, this is the parameter that's coming in. So if num is even, then you've returned true. If it's false, then you return false. And the last thing I asked was the java.comment, and that you just hit / and hit enter, and it'll form out this comment. That's really handy. And you can say checks if the param is even, return true if the number, if the given number, given int is divisible, cleanly divisible, or is even by 2. And this java.comment is super handy, because when I do like s dot and I read through these are all provided by those java.comments. So these little notes are really handy, which is why you'll often say, hey, write the java.comment for this, because these little things are pretty nice. Cool. Any questions?
So just for the java.comment, when is that necessary? Is it like, can you always use it, or is it just?
You always should do it at the above every method header. I will do this. I'll make you document this stuff to be a really popular, programmer that people want to hire. It's rarely, if ever, checked on the AP test. So this is something that putting in comments to describe this, and I saw some students getting rid of the comments after they did something, and that, why do that? Leave these comments in, add extra comments, so that way that when I'm reading your code, I can see, oh, you're doing this because I told you to make an infinite loop. So a description and context clues means your code is really helpful. And you'll be a lot of programmers are hired just to maintain and update other people's code. And so you're going to be so grateful if those notes are in there and giving you some help.